Last class we understood this setup of YDSE, Young's double slit experiment, and we discussed why and how interference happens, what is the meaning of bright fringe, what is the meaning of a dark fringe, what is a fringe pattern, and we explained this process of interference, this phenomena using Huygens principle. Okay. This lecture we are going to locate those points, those positions where bright fringe forms, dark fringe forms, where they will be located. Okay, what will be the angular position, at what angle, what will be distance from this point here. Okay, so this is a normal setup of YDSE. Okay, note down the meaning of all the terms. Okay, let me read it for you. S1 and S2. So I have these two slits. This is some kind of an obstacle, opaque obstacle. This is my screen. It's my screen here. Okay, where we obtain those fringes, dark and bright fringes. Okay. These two openings, they are two openings. We can also call them as slits or holes or apertures, very small, point-like, very small holes, okay, openings. S1 and S2. Okay, we are calling this slit. The general name is slit here. S1, S2 slits. Distance between them is D. Distance between slits. Okay. The screen is kept here. The distance between these slits and the screen. Okay, you see both are parallel. Both are parallel. Distance is D. Okay. Now we are going to study this phenomena, this setup under a very special condition. The special condition is that this separation between the slits and the screen is very large. This D is very large as compared to this small d here. Okay, it's like this. Okay, try to understand. If this distance is, let's say, 1 millimeter, two slits, two point-like holes at 1 millimeter, with very small separation, 1 millimeter, then this will be, let's say, 2 meters, 1 meter. Okay, so it will become 1,000 times more than this. So this is the meaning of this condition here. This is very large as compared with this. Point O is the midpoint of S1, S2. So this will become half D, this will become half D, midpoint. Now, a point right in front of this point O here is point C. It's right in front. That means this angle is 90 degree here and 90 degree here also. It's right in front. This is known as center of screen. Now, center of screen is not the center of screen. Understand this. Okay, my screen can be only of this length here. Okay, so this point is not actually the center of screen. It is not the geometrical center. This has a very specific meaning. Okay, the point which is right in front of this point here, that point I am calling as center of screen. It may not be the geometrical center, no matter what is the length of a screen. Okay, even if there is no part of a screen here, okay, then also this point will become center of the screen. Okay, try to, okay, keep this in mind. Okay, understand this. And then several other terms are also written. What is this? P is a general point. So on this point, the light from both sources, S1 and S2, they arrive and they interfere. General point. Now the distance of this point from center is Y. It is Y. And this angle here, this angle theta is known as angular position of P. Okay, this is my setup. Okay, a description about setup, different parameters. Keep this thing in mind. You draw the diagram now. You draw it, yourself you draw it. Okay, do not only look at this figure here. You draw the diagram, you draw it, and then let's start. Now what we are going to do? What we are going to do? I have to locate, I want to find out where will I get dark fringe, where will I get bright fringe. Okay, so let's do it. Now at point P, okay, at point P here, both waves arrive. What is path difference? Path difference between waves arriving at P, okay, a general point P, delta x is equal to mod of S1P minus S2P. Okay. I'm writing mod because you see this point can be below this center also. In that case, S2P, S1P will become more than S2P. Okay. Here I'm writing mod of this. Mod of this. It can be S1P minus S2P, or if you are feeling uncomfortable, I can write S2P minus S1P. I just have to be concerned with the magnitude only, not with sign, positive and negative. No, it does not matter. Okay. Now, what this will be? Okay, if D is very large as compared to D, then S1P and S2P are nearly parallel. They are not parallel. Okay, if they are parallel, how will they meet here? But they are nearly parallel. It's like this. I have this slit. One slit is here. Okay, one slit is here, and then there is one other slit here. Okay, this is S1 and this is S2. Okay. S1 and S2. Two slits nearby, and my screen is at a large distance. Okay, then at any point, if you look at these two waves, okay, they are coming from two very close points. Okay. It's like this. Okay. So you see, of course, they are not parallel. There is no doubt about it. Because if they are parallel, how they are going to meet? Okay, they are not parallel. What we are saying is that if this distance is very small as compared with this distance, then these two are nearly parallel. And then delta x will be equal to d sine theta. Okay. Now, if they are nearly parallel, in that case, if I draw a perpendicular here, then these two lengths are going to be same. The length starting from this point to this point will be same as length starting from here, from this point to this point P here. Okay, that means this is the path difference. This is the extra distance. Okay, here also, if I draw this perpendicular, then this angle is going to be theta. Okay, if this is theta, this is going to be theta. But this will happen only under this condition. Only under this. Okay, then this is the extra distance. This is the extra distance that this second light travels. Okay, so this will be the path difference, this delta x. This is the path difference between these two lights. So this is d here, this angle is 90 degree, this angle is 90 degree here. Okay, so this is theta, this is d, this becomes d sine theta. D sine theta. And that's what you have to remember. At this point, at angular position theta, what is path difference? Delta x here is equal to d sine theta. That's it. Under this condition. So at different points, theta is different. Depending on theta, d is constant. This is distance between the slits. This is constant. For different point, theta will be different. Theta will be different. Okay? If theta is different, delta x is going to be different. Path difference is going to be different. Depending on path difference, there will be phase difference. What will be phase difference? Delta phi. It is going to be equal to 2 pi over lambda times delta x. This is path. This is phase difference. Okay. Depending on path difference, the interference is going to happen. Depending on path difference, it will be either constructive or destructive. Depending on path difference. Okay. Or it can have any other intermediate values. Okay. Now, for constructive interference. Okay, let's find out location of bright fringes. Location of bright fringes. Okay. What is condition for constructive interference? Okay, delta x should be equal to what? It should be equal to. It should be equal to integral multiple of lambda. Integral multiple of lambda. Okay, so delta x is equal to n lambda. Okay, so this delta x, this is d sine theta, is equal to n lambda is equal to 0, lambda, 2 lambda, 3 lambda, like this. Okay? Do you understand this? What is this? This is the condition for bright fringes. Okay? What will be sine theta? Sine theta will be equal to 0. Okay? Lambda over d, 2 lambda over d, 3 lambda over d, and all. Okay, what are these? These are angular positions of bright fringes. Note it down very clearly. Very clearly. Whenever on this whole screen, whenever sine theta is equal to either of these values, I am going to get constructive interference. Intensity will be maximum and it will be known as a bright fringe. A bright fringe. Do you understand this? Okay? Now, near center. Near center. Okay? Theta is small. Theta is small. Okay? This is a condition for bright fringe anywhere on this screen. Anywhere. Okay? But near center, where the theta is small, okay, I can write sine theta is approximately equal to theta. Okay, is that fine? Now, so I can write theta is equal to 0, lambda over d, 2 lambda over d, okay, 3 lambda over d, and all that. Okay, understood? Now, so at 0 here, what is 0? This is the position of center. Okay, this is the position of center. Okay. This is center of the screen. Center of the screen. That means at the center of the screen, I am going to get a bright fringe. At the center of the screen, I am going to get a bright fringe. Okay, so here I am going to get a bright fringe. It is known as central maxima. Central maxima. Okay, or central bright fringe. Central bright fringe. Note down these names, they are very important. They are very important. At the center where theta is 0, I am going to get a maxima. I am going to get a bright fringe. It is known as central bright fringe. It is central maxima. Both are same. Now, what will be path difference here? At center of the screen, okay, theta is 0, okay, delta x is also 0. Delta x is 0. What is path difference? Path difference is 0. That means at the center of the screen, both light rays are traveling same distance to reach the center of the screen. Path difference is 0. Path difference is 0. Okay, it is also known as zero order maxima. Zero order maxima. Or zero order bright fringe. Note it down very clearly. Why we call it central maxima? Because it forms at the center. Why I call it zero order maxima? Because at that point path difference is 0. Path difference is 0. Okay, you understand? Okay, now let me clean all this. I'm going to clean all this, okay? I'm going to write something here. Now, on either side, path difference is 0 here. Okay, let me clean. Okay, central right fringe, central maxima, 0 order maxima, and all that, different planes. Okay, central maxima. Path difference is 0. Okay, at this point, path difference is 0. Try to understand it. As I go above this center or I go below, path difference starts to increase. At this point, it is 0. Okay, when I move ahead, when I go above it or below it, now path after some distance, at some position, path difference is going to be lambda. Again, I will get a maximum. Okay. Here, at this point, path difference here is going to be lambda. Okay. I will get a bright fringe. This is also a bright fringe. Bright fringe at center. If I move some distance up, path difference, you see, as I start moving, path difference keeps on increasing. Path difference keeps on increasing. Here it is 0. At some position it will become lambda. Okay. When I come down here also, at some position it is going to be lambda. Okay. We are taking the mod of these two, the difference, path difference. Okay, mod of this. Minus lambda plus lambda, both are same. It makes no difference. Okay. Here I am going to get bright fringe. I am going to get a bright fringe. Okay. What is the path difference? It is lambda. It is known as first order maxima. This is first order bright fringe. First order bright fringe. Here also, below also, I will get first order bright fringe. Now, when I keep on moving, at some point here, this path difference becomes equal to 2 lambda. 2 lambda. Okay. Here I will get second order bright fringe. Okay. And similarly here also. Here also at some position it becomes 2 lambda. It is known as second order bright fringe. Okay. Now what will be their angular positions? What will be their angular positions? I am going to clean all this. Okay. I am going to make space. What will be their angular positions? Okay. So angular position of the central maxima is 0. At what angle the next maxima will be obtained? Here. Okay. The next maxima here, at this point here. Okay. What is d sine theta? At this point, what is d sine theta? D sine theta is equal to lambda. Okay. What is sine theta? Is lambda over d. Okay. What is sine theta here? Sine theta is lambda over d. Okay. Here sine theta is 2 times of lambda over d. Okay. Here also sine theta is 2 times of lambda over d. Okay. Sine theta. So what will be theta? What will be theta? Theta approximately 2 lambda over d. Near center. Theta approximately lambda over d. Here also, you see? Okay, let me write it here. That means here sine theta is lambda over d, theta approximately lambda over d. Okay. So now this is the position. What will be this angle? This angle is lambda over d. Okay. And then the next maxima here. Okay. What will be this angle? What will be this whole angle? This whole angle is 2 lambda over d. So what will be this position here? This will be angular separation. Angular separation between two consecutive bright fringes. Okay, this will be equal to lambda over d. Lambda over d. Okay, that means the distance between these two. Distance between these two is lambda over d. Distance between these two is also lambda over d. But that will happen only when the theta is small, near center. Okay, this lambda over d is known as angular fringe width. Angular fringe width. Okay, did you get it? Okay, this angular separation between two successive bright fringes. Angular separation between two successive bright fringes. It is known as angular fringe width. Near center. Something you have to remember. A standard result. Okay, understood? Now let's look at the location of dark fringes. Location of dark fringes. That means it will be a destructive interference. It is going to be a destructive interference. Destructive interference. So this is going to be equal to odd multiple of lambda by 2. Okay, so it's like lambda by 2. Okay, 3 times of lambda by 2, 5 times of lambda by 2, and like this. Okay, that means d sin theta is lambda over 2. Okay, 3 lambda over 2, 5 times of lambda over 2, and all that. Okay, so sin theta is equal to lambda over 2d. Okay, 3 times of lambda over 2d, 5 times of lambda over 2d. These are the positions of dark fringes. The positions where destructive interference happens. The positions where intensity is minimum, they are known as dark fringes. Okay, now near center. Okay, theta will be approximately lambda over 2d, 3 lambda over 2d, 5 lambda over 2d. Now what will be separation between the consecutive dark fringes? What are these? These are location of positions of dark fringes. Okay, what will be angular separation between two consecutive dark fringes? Okay, this, if you find the difference, it is going to be same, lambda over d. This also is lambda over d. Okay, this lambda over d is known as angular fringe width. Angular fringe width. Okay, now let's look at the positions. Okay, this is theta is 0. This theta is 0. Okay, theta is 0. This is central maxima, central bright fringe. This is the first bright fringe here. First bright fringe here. What is theta? It is lambda over d here. Okay. Now where is the dark fringe? Dark fringe is at what position? It is half of this, half of lambda over d. That means it is going to be between this here. Here I am going to get dark fringe. Okay. This is the position of dark fringe. Okay. What will be path difference here? This will correspond to a path difference of what? Lambda over 2. This is lambda over 2. Okay. What will be sin theta here? Sin theta is lambda over 2d. Between two bright fringes, I get a dark fringe. Here also I will get a dark fringe. Here delta x will be equal to 3 times of lambda over 2. The path difference is going to be between these two. Here also this path difference is between these two path differences, 0 and lambda. Between them lambda by 2. Here also similarly I am going to get dark fringe here. This delta x is going to be lambda over 2. Here dark fringe again. This delta x is going to be 3 lambda over 2. Okay. So between two bright fringes, I get a dark fringe. And between two dark fringes, I get a bright fringe. Okay. So this pattern of alternating bright fringe and dark fringe. Okay. The whole screen is filled. It is filled with this alternating pattern of bright and dark fringes. It is known as fringe pattern. And these values give us the angular positions. They give us angular position. Okay. Now let's try to understand this again. I hope that you are able to see all of this clearly. Okay. I hope that. Let me focus it again. Okay. Do you understand this? Okay. So this alternating pattern, you start from center. At center, what is path difference? Okay. Let me write it. Let me clean this so that you can, okay, make more sense. I'm not writing the names again. Okay. I'm just saying that at center here, this is the central position. Delta x is why? Because both light waves are traveling same distance. There is no path difference. This is known as zero order maximum. Where when I go from this point in either direction, I go up or I go down, path difference starts to increase. It starts to increase. Okay. At some position, it becomes lambda by 2. Destructive interference, dark fringe. I keep on going. It becomes lambda, bright fringe. 3 lambda by 2, that means 1.5 lambda. This is nothing but 1.5 lambda. It becomes dark fringe. 2 lambda, bright fringe. Then 2.5 lambda. Here delta x is 2.5 lambda. Okay, this is again a dark fringe. Similarly, same thing is repeated when I start coming down. Bright fringe, dark fringe, bright fringe, dark fringe. Okay. What will be angular separation between two consecutive bright dark fringes? Okay. If you look at one dark fringe here and the consecutive, the successive here, this is the second dark fringe. Okay. This distance here is going to be lambda over t. This is known as angular fringe width. Okay. What will be angular positions? Angular positions. Okay. Here, sin theta is going to be 0. For this position here, sin theta is lambda over t. In between, for the first, this is the first dark fringe. Okay. Do you understand all of this? I'm going to clean it. I'm going to make some space for writing something else. Okay. Keep on noting all of this. Okay. Draw this diagram several times. Okay. Several times on different pages. You draw it. You understand this figure. You understand this chapter. You understand this figure. Everything is contained in this figure. Everything. You understand this figure. You understand this whole chapter. Okay. Keep in mind. I'm going to make some space here. Okay. Okay. Now this middle point here, right in front of it, is center of the screen. Now this is central maximum. This is central bright fringe. Central, 0 order. Then first order bright fringe. Path difference lambda. Second order bright fringe. Path difference 2 lambda. Nth order bright fringe. Path difference will be n lambda. Okay, you understand this? Now, this is known as central. This becomes dark fringe. This is bright fringe. This is first bright fringe. On either side. Okay. This becomes bright fringe here, dark fringe here. Okay. This becomes first bright fringe. Understand this nomenclature. This is not first. This is 0 order. This is central bright fringe. On either side, I am going to get first bright fringe. This becomes second bright fringe. Similarly here also. Okay, this becomes second bright fringe. Okay, this is first dark fringe. Let me call it as D1. This is first dark fringe. This is second dark fringe. Similarly here, this is first dark fringe and this is second dark fringe. Do you understand this? Path differences 0, lambda, half lambda, lambda, 1.5 lambda, 2 lambda. Okay? Now, one other very important thing. Okay? Zero order, first order, second order. Okay? Do you understand this? Now let's write one other thing. Let me write. Okay? Central maxima. What will be phase difference? What is phase difference? Delta phi is 2 pi over lambda into delta x. Path difference is 0, phase difference is also 0. What is phase difference here? This is the first dark fringe. What is phase difference? When I write lambda by 2, it becomes pi. Here, this is first order. What is phase difference? Delta pi. It is 2 pi. Okay? Here, delta phi. This will be equal to 3 pi. Okay, keep on putting these values here. You will get phase differences. Okay? Here, delta phi is going to be equal to 4 pi. Okay? Now let's come down here. Delta phi is going to be equal to pi. Delta phi is 2 pi. Delta phi here is 3 pi. Okay? Delta phi here is 4 pi. Okay? This is bright fringe. This is dark fringe. Bright fringe. Dark fringe. Bright. This is dark. Bright. Dark. Bright. Notice the pattern. That's all you have to understand. Okay? Notice the pattern. Path difference, bright fringes, multiple of lambda. Phase difference for bright fringes, multiples of 2 pi. 0, 2 pi, 4 pi. Okay? Alright? Path difference for dark fringes, lambda by 2. 3 times of lambda by 2. Odd multiple of lambda by 2. In terms of phase differences, odd multiple of pi, 3 pi, 5 pi, 7 pi. I will keep on getting more and more dark fringes. Okay. Now, all of these are in terms of path difference, phase difference. We just discussed the angular positions. Angular position. What about distance from center? What will be distance from center? What will be distance from center? This is at the center. Now what will be the distance? The linear distance. Linear distance between two bright fringes, between two dark fringes. What is the distance of any bright fringe from center? Okay, let's try to derive expression for that. Okay, let's try to derive expression for that. Okay, did you note all this? Did you note all of this? I'm going to clean it. I'm going to clean. I'm going to draw another figure. Okay, another figure. The only thing is I will not have to make much effort. That's it. Now here itself I can draw the another figure. Okay, this is bright fringe. Of course this is bright fringe. Not only bright, but it is known as central bright fringe. Central bright fringe. Now, central bright fringe. Okay. In terms of distance from center C, in terms of distance from center. Okay, let's take one general point here. One general point P. Okay, this angle is theta, and this distance from here to here, this distance is y. Okay, can I clean all of this? Okay, let me clean all of this. Okay, let's do this again, like in a fresh new figure. Okay, in a fresh new figure, let's do this again. It's not difficult to draw it again, very simple. S1 and S2. Okay, so this is a general point P. This is the angular position. Angular position theta. This distance is D, and this is a capital D here. This is capital D. This is O. This is C. So this becomes capital D. This distance is Y. What is Y? This distance of this point from the center of the screen. Okay. Path difference here delta x is equal to d sine theta. D sine theta. Okay. Now near center. Okay. Near center, that means theta is small. Theta is small. Okay. Sine theta is approximately theta is tan theta. Okay. So delta x is equal to d sine theta. It is approximately equal to d tan theta. Okay. So delta x is equal to d into y over d. A very important expression. Very, very important expression. But that is near center. Near center. This is at any position. Okay. Everywhere. Okay, so this is equal to d times of y over d. This is something that you will remember. Remember this thing. In our problem, if nothing is specified, then we can apply this. Provided that you have to read the problem. If the problem it appears that it is talking about near center or it is not specified. For example, if theta is 30 degree, if theta is 1 degree, 2 degree, okay, very small angle, 1 degree, 2 degree, 3 degree like that, then I can apply this approximation. Now, if in the problem it says that what is path difference at position 30 degree, okay, or if this is 2 meter, they will ask you what is path difference at a point 1 meter from the center, 2 meter from the center, then it becomes a large angle. It becomes a large angle. Then I cannot apply this. This I can apply always, all the time, but not this. Okay? Okay? But here, let's look at this special case, near center, around center. Now, what will be position of bright fringes? Bright fringes, okay? So this delta x should be equal to 0, lambda, 2 lambda, and like this, okay? It is equal to n lambda. It is equal to n lambda, okay? So delta x, this should be y times capital D is equal to 0, lambda, 2 lambda, and all that. Okay? This y is equal to 0, lambda, capital D over small d, 2 times of lambda capital D over small d, 3 times of lambda capital D over small d. So it's like n times of lambda capital D over small d. Like this. This becomes central bright fringe. This becomes central bright fringe. Now, this is the first bright fringe, second, third order. First order bright fringe. This is zero order bright fringe. First order, second order. This is first order, zero order, first order, second order, third order, all that same sequence. What is distance between these two? It is lambda d over d. What is distance between these two? It is again lambda d over d. Lambda d over d. Now this value here, what is this? This is linear distance between two consecutive bright fringes. Okay, it is known as linear fringe width. Linear fringe width. Fringe width or only fringe width. only fringe width, okay, omega is equal to lambda capital D over D. A very important relation. Very important relation. This is distance between two successive bright fringes. Two successive bright fringes. Okay, let me clean all of this here. Let me clean it here. Okay, and let's just mark those points. Okay, so this is my central bright fringe. Central bright fringe. Okay, this is my first bright fringe B1. This is my second bright fringe B2. What will be distance between these two? It is going to be equal to fringe width. Okay. What is distance between these two? Okay, it is going to be fringe width. Okay. Below central position also. This is my first bright fringe. Okay. This distance is going to be omega. Okay. B2. Second bright fringe. Okay. This also is going to be omega. Omega. And what is omega? It is lambda d over t. Omega is lambda d over t. That's it. Okay. What will be position of nth bright fringe? Okay. Position of nth order bright fringe. Okay, is equal to n omega. Okay, from center. From center. Does that make sense? Perfect sense? Okay. Now, what about dark fringes? Do you understand all of this? Okay, we are combining everything now. In terms of distance, okay, bright fringe. Now, what about dark fringes? Okay, what about dark fringes? Dark fringe delta x is going to be equal to lambda over 2. Okay, so or multiple. So lambda over 2, 3 times of lambda over 2, 5 times of lambda over 2, and all that. Okay, so this is d and y over d is equal to all the values. So y, what is y? Distance from center. Distance from center. This is y. It is going to be equal to, okay, half of, okay, or lambda times d over 2d. Okay, it is 3 times of lambda over d over 2d. Okay. 5 times of lambda over d over 2d here. Now what is distance? Okay, now what are these positions? What is this position? What is this position? This distance. This distance y. This is my central maximum. Okay. What is y here? What is y? Y is distance from center. It is equal to lambda d over t. What is distance from center here? 2 times of lambda d over t. It is equal to 2 omega. It is equal to omega. Okay. Now here also y is lambda d over d. This is omega. For this position y is 2 times of lambda d over d. This is omega. Now this position, this is the first dark fringe. This is the first dark fringe. This is the second dark fringe. This is the third dark fringe. What is distance between them? Okay, it is lambda d over d. Here also same distance, lambda d over d. Okay, so this is known as omega. Omega. This is fringe width. So distance between two consecutive dark fringes or distance between two consecutive bright fringes, both are same. It is known as fringe width. It is known as fringe width. Okay, this is fringe width. Okay, you understand this? And then where they will be located? First bright fringe at a distance of omega. Okay. In terms of omega, how can I write it? In terms of omega, I'm going to clean all this. Okay, you should note it down. In terms of omega, that is fringe width. Okay, this becomes omega over 2. This becomes 3 times of omega over 2. This becomes 5 times of omega over 2. Okay. So here, this distance, that means it is it is exactly between 0 bright fringe and first bright fringe. Okay, this y is going to be lambda d over 2d, which is omega over 2. Okay. Similarly here on the other side also d1. Here also y is lambda d over 2d. It is omega over 2. Okay, so this is 0, omega, half omega, omega. 1.5 omega, 2 omega. It will continue in the same sequence below also. Okay, everything clear? And what is distance between two dark fringes? One dark fringe here, other dark fringe here. Distance between these two dark fringes, it is going to be omega. Okay, now distance of nth bright fringe, it will be n omega. N omega. What will be distance of nth dark fringe? This is the first dark fringe. First dark fringe. Okay, I can write this as omega minus omega over 2. Second dark fringe here, y will be equal to 3 times of lambda d over 2d. This is 3, this is 1.5 omega. Okay, or 3 omega over 2. This I can write as 2 omega minus omega over 2. Finding the position of nth bright fringe is direct, n omega. It's easy to remember. Position of nth bright fringe, n omega. Easy to remember. What about nth dark fringe? Okay. What about nth dark fringe? Position of nth bright fringe. Nth bright fringe is equal to n omega. N omega. Nth bright fringe. Okay. Nth order. Nth dark fringe. Okay. So you see, look at this. First dark fringe is equal to position of first bright fringe minus omega by 2. Position of second dark fringe is equal to second bright fringe minus omega by 2. So I can generalize it and write it like this, n omega minus omega by 2. Okay, so I can write it like this, position of nth bright fringe minus omega over 2. N omega minus omega over 2. Okay, what is omega? Omega is lambda d over d. Okay, path difference at point P. Okay, delta x is equal to d sine theta is approximately equal to d into y over d. Okay, if theta, or let's say near center. Near center. Okay, angular positions. Angular positions of bright fringes sine theta is equal to 0, lambda over d, okay, 2 lambda over d, okay, like this. Okay, for dark fringes, sine theta is lambda over 2d, okay, 3 lambda over 2d. Okay, so between two bright fringes, I have a dark fringe. 5 lambda over 2 and all this. Fringe width, this. Angular fringe width, this is linear. Linear fringe width, okay. Angular fringe width, it is equal to lambda over d. Near center. Near center. This also is near center. Okay, so I think that's it. We did almost everything. Okay, note down everything. Try to assimilate. Try to assimilate everything that we did. Okay, this figure will work as a reference for us. Okay. Okay, then forget about this video. Try to assimilate everything. Try to absorb everything that we discussed. try to internalize it into your head. Okay. Then from the next class, we are going to discuss problems. For the next few classes, we will be doing problems only. Okay. Keep all of these things in mind, everything in mind. Note down all the formulas at one place. There is no formula as such. Okay. Only if you remember this condition. Okay. For this, starting from this position, starting from this formula, we derive everything. Okay. So you just have to remember path difference at a given point, at a general point, and what are the positions. Okay. It's easy to remember it in terms of omega, path difference, this fringe width. What is path difference? Relation between path difference and phase difference. Okay. Path difference for a given order of bright fringe. When I say 10th bright fringe or 10th order bright fringe, what is going to be path difference? Path difference will be 10 lambda. In such simple terms, we just try to remember it. Next class, we are going to do just problem, only problem. Okay. All the theory, everything that is required is complete now. Okay. Next class, we start with problems.